So in order to understand how to solve an equation, we first must understand some opposite operations. Now, what do I mean when I say opposite operations?
You mean like divide? There's divide and multiply.
There's divide and multiply. So why do I call that opposite operations? They're opposite. So if I say 2 times a number, 2 times we'll say x, then the opposite of that would be dividing, right? So they cancel each other out is what I want you to see. If I took the same 2 times x and I divided it by 2, what happens? They're opposite, so they cancel and just leave the x. Okay? So and we can go the other way with that. If I had this number x and I was dividing by something, what's the opposite of dividing? Multiplying. So if I had this times 5, then these would cancel and leave me with x. They're opposite operations, meaning they cancel each other.
What do we have to do?
We're gonna set up where they do. That's what we're gonna try to get to. But I want you to understand the opposites here.
Oh my gosh, I missed the blankets.
Besides divide and multiply, give me 2 more opposite operations. Add and subtract.
Multiply, divide.
Okay. So we got multiplication, division, and addition, subtraction, and that's really all we're going to work with today. So let's say that I have some number and I add 4 to it. The opposite of adding 4 would be subtracting 4. And so if I did this, well, these would cancel and it would leave me with x. 4 minus 4 is 0. Get the variable by itself. Get rid of the numbers, right. The reason this works is 4 plus negative 4 is 0, and anything plus 0 is itself. Okay. With the multiplication and division, the reason that it works, if I have 2 times x and I divide it by 2, well, what is 2 divided by 2? It's 1. So it's 1 times x, which is just x, okay? So that's why it works, okay? It gives us the identity of that operation. But it gives us that identity. All right, so let's apply this a little bit. And here's where it starts getting into the algebra part.
Oh goodness.
Actually, before I do.
It's almost 8:30.
No, it's not. Okay. So what I'm going to be dealing with here is equations. We've dealt with expressions before. What are algebraic expressions? No equal sign, numbers, variables, and operations, right?
Yes.
But an equation has all those things, but it also has, so expression, I'm going to say expressions because we can have stuff on both sides, with equal. So if you see equation, think equal, you know it's got an equal sign. So let's think about an equation. I'm going to do the algebraic expression x plus 7, yeah, equals 10. Is that an equation? Why? It's an algebraic equation. It's got a variable, numbers, operation. The key here is that equal sign in the middle. Tell me what you know about equations.
They got numbers. Whatever.
They equal the same thing, okay? And that's key. So think about, have you ever seen those scales before? You put something on the right side and it doesn't balance it. Right. So that's the way you got to think about an equation. I can do whatever I want to an equation. But if I do it to one side of the equation, I got to do that exact same thing to the other side so that it stays balanced, okay? So anything we do to one side, we must do to both sides. So now the question is, how do you solve an equation?
Figure out what X is.
That's exactly right. When we solve an equation, we find what x equals. In other words, we get x by itself. I know I'm going all over here on your notes, and I apologize. Sorry. I'm going to give you a second to copy that down before we... So let's look at this equation. So I'm back to the x plus 7 equals 10. And I'm going to go to the next page so we got room to write here. All right. The question is, how do I get x by itself? What's keeping x from being by itself? The plus 7.
On each side.
So
with this.
what I do is I want to look. 7 is added to x. So how do I get rid of it?
You got 7 subtract to x.
I do the opposite of adding. So I subtract x. That would make it go away, right? Or subtract 7, I'm sorry. That would make it go away. Do we all agree?
Yes. You say it again.
So, right, the way it sits now, x has got a 7 hooked to it, right? It's added to it. So I need to do the opposite so that it cancels out and it gets rid of it. So the opposite of adding 7 would be subtracting 7. But think about those scales. If I take 7 away from one side, I got to take 7 away from the other side also. So I'm going to take 7 away from both sides, and I'm just going to set it up like this so you can see your step. Yeah.
And it'd be like this.
Yep, to myself.
Huh?
Oh! All right. So look at the left side. Because I've done opposite operations, these are gone. They cancel, right? So what's left on the left?
3.
What?
You're right for the right. You're a step ahead. It's okay. It's okay. X equals, and now if I take 7 away from the right, I'm left with 3. Now, I'm not sure I'm right. I'm going to check my answer. I hope y'all realize I'm really bad. So to check, and we did this on our last test, guys, and you did really well. So to check, I want to plug in and make sure it's a solution. You know how before we were saying, is this a solution, yes or no? It better be a solution if that's what you got. So to check, I plug it in. So come back to that original equation. That's why we did that, yes. I'm going to plug 3 in for x, so 3 plus 7. Does that equal 10? Yes. So yes, it is a solution.
Then you got your x wrong. Wait, it's not a solution.
Number 2. Let's throw a negative in there. What is keeping x from being by itself? Minus 10. What's the opposite of subtracting 10? Adding 10, right? So I'm going to add 10 here to get it to go away. But again, it's an equation. I got to keep it balanced. So I need to add 10 over here also. Left side, the 10s cancel, yes? How about the right side?
That's 7.
That's 7. Good job.
Oh, the sounds of difference between subtract. How is it up on the?
Negative 3 plus 10.
You got to subtract the size of difference.
Make sure, use your calculators too to check, because you can have the calculators all day long on EFC, so make sure you use them. Because that's where more students make mistakes, is you make a careless mistake. You know what I'm saying? You look at it and go, wait, 3 and 10 is 13. But you miss that negative sign, or you do it in your head. So if you make sure you use that calculator, it'll really, really help you. All right, let's check it. Let's do a check. Again, use your calculator. 7 minus 10, does that equal negative 3? Yes, negative 3 equals negative 3, and it checks. No, you're not. Don't say that. No, you're not.
I'm not the brightest bulb.
Sure you are. Let's look at a multiplication one. Oh, Lord. This time, what is hooked to the x? What is being done to x? It's being multiplied by 6. Do we all
You gotta go under it and do.
So the opposite of multiplication is dividing, division. So if I divide, I'm going to do this just like a fraction. We know what that means, right? This means divide. A little more sophisticated than the little division sign. But because it's an equation and I must stay balanced, I got to do it to the other side also. Okay? So on the left, because I've multiplied and divided by the same number to x, those go away. And I'm left with x equals, well, what is 48 divided by 6?
8.
So let's check it. I hope this is simple. I mean, you're watching me do it right now. Let's do a check. 6 times 8. Is that true or false? It's true. It works. It is most definitely a solution. Is anybody confused?
Are you confused? Are you confused? Are you confused?
What if I started out
Oh my goodness. Oh my Gigi.
like this? What is being done to x here?
It's being divided by 3, so you use plural.
Exactly. It's being divided by 3, so the opposite of dividing by 3 is multiplying by 3. Because that's not hooked to the x. I'm only looking at what's being done to x, because I want x by itself. So I'm going to multiply by 3. Again, it's an equation. If I do it to one side, I got to do it to the other. So this was a little bit of a trick, because 21 is a factor of 3. I was thinking some of you might divide instead of multiply, but we're smarter than that. These are gone now. So I get x equals, and use your calculator. You should get negative 63. To check it, again, use your calculator here to see when you divide those two numbers, do you get negative 21? Yes, you do. So yes, that is a solution. I hope this is easy for you so far.
Yes.
There's one little thing that I want to show you.
My notes are so beautiful.
Okay.
I'm talking about a whole nother page.
And of course, it's going to be fractions, and that's what always throws us.
I'm so sleepy.
Let's talk for just a minute about fractions. if I had 2/3 times x equals, let's see if I flip it to, equals 4. Okay. The 2/3 is being multiplied, right?
Yes. But
It's being multiplied by x. So we know that the opposite of multiplication is divide. Here's the trick. Here's the trick with fractions. Fractions are kind of difficult to work with sometimes. I'm going to give you a rule of thumb that will take you through the rest of high school. This will help you out always, always, always. Never divide by a fraction. So the question is, well, Spaghetti, if I'm not dividing by the fraction, what in the world am I going to do? Instead of dividing by a fraction, I'm fixing to show you. We're going to multiply by the reciprocal. What does reciprocal mean? Does anybody know what reciprocal means? You reciprocate something. It means you flip the fraction over. Okay? Multiplying by the reciprocal or the flip is the same thing as dividing. Let me show you why. If I have the fraction 3/4, what is the reciprocal of 3/4? 4/3. So let's multiply reciprocals together. When you multiply fractions, you multiply top times top, bottom times bottom, right? So on the top, I have what? 12.
Over 12 and that equals uno.
So, multiplying by a reciprocal cancels it out. Okay?
Oh,
It's a lot easier than trying to divide. If you came over here, you said, okay, I'm going to divide both sides by 2/3. Well, how do you divide 4 by 2/3?
Wait, we did the wrong number.
But,
Why didn't we do 2/3?
now we're going to come over here and do it. But if I come to this side and I multiply by 3/2, because that's the reciprocal, and remember this is an equation, so I need to do it to both sides. I've got a whole number. I can make that a fraction easily, right? These we know cancel. Reciprocals give you 1. They cancel out. So x equals, what's on top?
That's it?
What's 12/2?
6.
Now take out your calculator and let's check. When you put a fraction in your calculator, what you want to do is you want to do 2 divided by 3. Make sure you put it in parentheses. Times 6. And see if you get 4 when you do that. So parentheses 2 divided by 3. And then close parentheses times 6. You got what?
Mine, I got 4, but
That's
for
correct.
mine, it's like a
Oh, that's fine. Yeah. Okay. So yes, it checks. Let's do one more like this.
Oh my goodness.
Let's change the variable up a little bit too. This is the last one.
Are you sure?
Sure. So directions say to solve. So I know I need to get W by itself, right? What operation is being done to W? It's being multiplied, right? The fraction's being multiplied. That's okay, we're going to look. The fraction's being multiplied.
Oh.
The opposite of that would be division.
Stop!
Why are you doing that? Alright, so it's multiplication, but, and I think this is what you were getting at, you were just getting ahead of the game. How do I get rid of that fraction that's being multiplied? Good job. Good use of the word, Kennedy. I reciprocate the fraction. You even changed the tense of it and everything. Conjugated it. So I'm going to multiply because normally I would divide, right? I would divide because I'm multiplying. But since it's a fraction, the rules are a little bit different here. And I'm going to do 6 over 5. Six, what'd you say? 60?
Wait, how y'all did that?
Top times top and bottom times bottom. Straight across when we're multiplying. Top times top, bottom times bottom. So what is 60 over 5? 12. And you can use your calculator. So 12. So now let's use that handy dandy calculator and let's check to ensure that we got the right answer. So again, 5 over 6. So you'll want to put it in parentheses if you've got a scientific calculator. Does that equal 10? Yes, it does on our calculator, so we're good to go. In the original, that's what we got, so we plugged it in for W. Just to check to make sure. 60 divided by 5. Tell me give me a thumbs up, I got it good, I don't need anything else. Sideways thumb, it's okay to me, and down, I don't got it at all.
It's okay to me.
Okay. Ramon, where's your thumb? You got it? Okay. All right.